the reasoning would be the same. So you cannot find an x. Now this x, remember, belongs to your set of reals. You've got two reals here. So any positive, negative, whatever real number here, you plug that into your formula, if you like, your function f, and whatever it is, plus or minus, you'll get a positive number, but you won't get 0 or negative. Okay? So just choose an element 0, and all, like, here are all your positive reals. So this is just R plus. Okay? So everything maps into that range. Right? That's your image set or range, same thing. Right? Image set range, synonymous. But look, here's a straggler. Okay, so it's not surjective. All right, so that's done. All right. Now, question 3 is the other way around. Give an example of a function. Again, f r to r. So 3. So f maps the reals for the reals, and your f. Well, that's what you got to find. Okay. Now it is a surjection, and it's not an injection. So find an example that would do that. And again, these open-ended questions are tough, right? You can just sit there and thinking. Well, depends how smart you are, I guess, and creative. So again, I'll just throw it at you, the answer. Choose an f of x, and you'll see, when I write it down, you'll see why it's not so obvious. Okay, x to the cubed minus x. Gee, it's plain as day, right? Okay, but why does this work? Let's see. Well, let's prove that it's surjective first. I mean, it doesn't matter, but okay. Now, how to prove that something is surjective? So use this strategy. Okay, so take two values. So like f of a, and we'll say that they're equal. So f of b. So that means that a cubed minus a equals b cubed minus b. And well, you can expand that out into a product. Well, you know, a is b. I've skipped a few details, but essentially it comes out as that. Okay, so it's injective, right? Because prove that. Now, what am I saying? I'm getting confused. Which? Hold on. It is a surjection, but not an injection. It is a surjection. Sorry. It was this thing that threw me off. Okay, so to prove a surjection, so that means you just have to, for each element in B, you have to find an A that maps to it, or at least one. Right? So so choose an arbitrary y belonging to B. Right? So that means that, and we're trying to find an x such so that'll be equal to y, right? Because it belongs to B. So y then equals x cubed minus x, and you can that's just you can solve. That's a cubic equation. You can solve it, right? And you can find a value of y. So therefore, it's surjective. All right. Now, why is this function not injective? So to disprove something's injective, let's try to find, there's an element here that gets mapped to many to one. Right? So, try this. So what is f of naught? Well, that's just naught minus naught, which equals naught. Right? And what's f of 1? Well, that's 1 cubed, so that's 1 minus 1, also 0. So that's why Barnard probably chose this to get something like that. Now it's not obvious, but anyway, you can see that it works, right? So you now have two elements from your set of reals, right? 0 and 1, they belong to this set of reals, and they both map to 0. Both of them. So 0 and 1, and they both map to the same element. And therefore this mapping here is not injective. It's not an into function. Alright. Okay. Now let's do a bijective question. That's the fourth. Your function maps the non-zero reals. That's with a star. You throw out the 0. So the non-zero reals to the non-zero reals, and your function is 1 over x. Okay. Now, if x is 0, that would be a problem, but in this case it's not, because you're not allowed to have 0 in R star. Okay, so how do we prove? We have to prove this function f is a bijection. Okay, so that means it's an injection and a surjection. Or to use the other terminology, this function is an into function, or an into mapping, as well as a onto mapping, or a surjective mapping. Right? So which will we do first? Let's do injective or into. So how do you prove an injection? Well, again, you just take two random elements. So let's just take two random elements belonging to your domain, so A and B, and then assume that they map to the same element. So you assume that f of A equals f of B. In other words, 1 over A equals 1 over B. And then you have to prove that these two elements in your domain are actually equal. Well, gee, that's not hard, right? Just invert both of them, just get A equals B. All right. So you have proved injective, and you have to prove now surjective. Okay. So for any A belonging to A. Well, so here's a Y belonging to B. Right? And we're trying to find, and this is a random member of your codomain B. So we're trying to find something, some element that gets mapped to Y, for any Y, given this function. Well, how about 1 over it? Okay. So what would that map to? So you just need to find a member of your A, of your domain, that maps to it. And if that's true for whatever element you choose for your B, for your codomain, if you can always find an element that maps to this random member of your codomain, your target set, if you can always find something, so then you know that it's always mapped to. Okay? Everyone is mapped to. So let's try this one. Well, what is f? It's, where is it? It's the inverse, okay? So f of 1 over y, and we suspect your little a here is